All right. Hello, everyone. I think we will go ahead and get started. This is being recorded, and I'll have the recording posted a little bit later. So if anybody comes in a little bit late, and we are broadcasting on LinkedIn. All right. Hello, everyone. Give me just a second. I think we will go ahead. Yeah, we are broadcasting on LinkedIn. I believe that you should be able to use the comments on the video on LinkedIn in order to ask questions as we go through. There's a lot of content to cover today. So a quick recap as far as where the topic came from. I did a poll after my last webinar on Salesforce ISV DevOps of what people wanted to see the most. This was one of the ideas that I had proposed about using GitHub and for Salesforce DevOps and kind of the unique features of GitHub that apply. And it kind of, I think 2-to-1 over all the other options was the number one vote. So that's where this topic came from. And I'm actually really excited about it. I've been using GitHub for, I don't know, over a decade, really extensively for the last decade in implementing Salesforce DevOps using GitHub. So really excited to kind of share some of what I've learned along the way. All right. So quickly, introduction to me for those who do not know me. I am Jason Lance. I'm the founder and president of MuseLab, which I created in April of 2022. After about 8.5 years at Salesforce.org, where I built out and ran the release engineering team, running some of the largest scale ISV release operations on the platform and building a whole suite of open source tools, Cumulus CI and Cumulus Suite, to do that. Those tools and ISV DevOps is what I talk about most of the time, but that's not actually really the topic of today. A lot of what we're talking about is generally applicable to anything that you want to try to automate through version control in your DevOps process for Salesforce. So quickly, introduction to MuseLab. We are really focused on this new model, the product delivery model that's focused on automating kind of complete experiences or the delivery of complete experiences into orgs from version control. It's a model that we built up at Salesforce.org, and a lot of the open source tooling is built around. We're not an SI, we're not a PDO. We try to help people kind of implement this particular practice and skill set, and it kind of applies across. Our focus is really on composable development, ISVs, and packages. We do a lot with open source and build a lot of what we build is on top of open source. We release our own open source. And really, we're kind of moving towards this vision of building a complete internal developer platform for Salesforce backed by GitHub. Really quickly, our services, which I'll talk about because a lot of what I'm showing today and kind of talking about are lessons that I've learned as I've been rolling out some of my services engagements with clients. Generally, my engagements are mostly with ISVs, walking them through a process of kind of understanding their challenges, rolling out a new CI/CD process on GitHub to development, automating the release pipeline with GitHub Actions, and then fully automating an integration recipe, achieving the product delivery model vision. I just mentioned this to kind of highlight that's kind of what we do, and that's the context of the information that I'm providing today. All right, so here is the very detailed description of everything that we're going to cover today. So at the bottom is basic version control. I'm not really going to spend a whole lot of time on this. There's a lot of information out there just about kind of branching and tagging and commit messages and things like that that are baked into version control. I would generally call those Git. And then GitHub is a Git host that hosts your Git repositories, or a VCS host, version control system host. And it provides a lot of extra functionality on top of what Git provides by itself. So I've grouped these into kind of 4 main categories, which are, I think, the easiest way to think about it. The categories are access management, CI/CD, process and compliance, and artifacts and collaboration. And I have slides on kind of some details on some of these individual things, and then we'll go through and look at what these actually look like in a GitHub organization and kind of play around with them. So, all right. So in the access management front, if your development process is centered in GitHub repositories, you need to control access to it. This is a core part of any audit compliance that you do. GitHub has kind of four main features, I think, that factor into this. The first is in a GitHub organization, you could build teams. Teams are related to members or other users and to specific repositories with a role. So for instance, a team, a group of people might have access to a certain repo with read access, a certain repo with write access. Organizations group together repositories and teams, and users are members of organizations. So that's the standard out-of-the-box functionality that you get. You can use those with the free edition of GitHub or with the GitHub Teams edition. I am a huge proponent of GitHub Enterprise. I did go through the process of becoming a GitHub partner, but I'm not getting any money from this promotion or anything like that. But I really do think that their enterprise package is really compelling with everything that it offers, and we'll talk about some of those things as we go through. But one of the biggest things is that enterprises allow you to have multiple organizations. So an enterprise is kind of this extra layer on top that allows you to apply policies across all of your organizations and manage them in a consistent way. It also allows you to set up SAML single sign-on. So that is really, really beneficial if we're locking down and controlling access to the process. And then finally, there is a feature called custom roles, and custom roles are allow you to define, basically custom roles in at an organization level that apply to individual repositories that you can then assign to users. And then your applications can interpret that role or use that role for whatever purpose you need. So there's some flexibility in the access management that's added by custom roles, which I think are a fairly recent feature in GitHub. So then on the CI/CD front, I think a lot of people are familiar with GitHub Actions. I don't want to cover them in exhausting detail. There's a lot of great documentation on building them. But there's a couple of features of GitHub Actions that I wind up using a lot in my work and wanted to kind of share and highlight those. So if you've not worked with GitHub Actions before, it's basically a kind of scripted action that is defined in the .github workflows directory with the action name .yaml as the file name. And it has an on section in the YAML that defines what triggers the action. So on could be push to a certain branch. It could be a pull request against a certain branch. It could be a new issue creation. There's a ton of GitHub events that you can trigger actions on. And then you get to run whatever automation you want, already have connection to GitHub and everything within the context of the action. One of the other things that you can do with actions, though, is build actions that can be manually triggered. So for example, if you define an action that's triggered on the workflow dispatch event, this is an event that can accept input. So it prompts the user when they go to actually run it, but a user manually runs this from the GitHub interface by clicking on Run Workflow and filling out the form with the required information. So this is a good way to automate processes that you want to manually trigger. So a good example of this that most of pretty much all the ISVs that I work with use this for their production release flow. So if you want to create a production version of a package, that's a manually run automated process. So one of the other things that I really recommend as a best practice as you go to build out your GitHub Actions is really think about the possibility or the likelihood that down the road you will be working in more than one repository. What I see often is that people kind of violate the don't repeat yourself principle here. We're engineers, but we don't really apply engineering to kind of this, this area. So we wind up writing kind of just a bunch of scripts that are duplicating things. And if we need to have the same logic in a different repository, we just duplicate hundreds of lines of logic. If you do that across many repositories, it becomes kind of a maintenance nightmare. GitHub Actions allow you to build reusable workflows. You define an event trigger called workflow call. It can accept inputs. And then in a repository, you can have a workflow that's defined that just points at that workflow, that reusable workflow, passes it the right values, and inherits all of its logic. So this way you can modify the logic across many repositories from a single place. All right. So next up is thinking about the pricing for GitHub Actions. This is my general assessment. Don't take these as the actual pricing or kind of based on this, but you can go out and do your own calculations based on what they have posted. But in the free plan, you get 2,000 minutes. Team plans, you get 3,000 minutes, and enterprise plans, you get 5,000 minutes of actions runtime per month. That equates to roughly 33 hours, 50 hours, and 833 hours of automation runtime that you get included in your license. Even with GitHub Enterprise, if you have 2 users in GitHub, you still get those 50,000, which is pretty interesting. I'm using that myself. Most of your builds for Salesforce don't actually need much. So you're actually getting the actual per minute pricing. If you use the bigger build engine or the bigger build systems with more CPUs and things like that, it has a multiplier for the number of minutes. But for Salesforce stuff, you're not really doing anything compute heavy in the build image. So the extra runtime beyond that is billed at about 42 cents per hour. I think that this is still pretty cheap. It's not anywhere near as cheap as what you could get with like AWS Fargate or something like that. If you want to get that, you can use self-hosted runners, and GitHub allows you to use self-hosted runners, and they charge you nothing for any of the runtime minutes. So you can provide your own runtime environment for it if you're going to be going way over the 50,000 and running a whole bunch of build hours, and that 42 cents an hour is going to be cost prohibitive. All right. So the next thing is, in order to run CI builds, you need to be able to provide secrets and variables to the build scripts, especially if you're using reusable build scripts, where you want to have kind of common, secret names and variable names, or you want to be able to pass those into a reusable build script. So in GitHub, secrets and variables are both types of variables. Secrets are meant to be for secrets and credentials. They are more security protected. Variables can be read from the API, secrets cannot. So you can post a secret from the API, you can't actually get a secret back. A secret's only available inside of a GitHub Actions worker when it's executing and authorized to use that secret. So secrets can be defined at the organization or at the repository level in GitHub, and they work like environment variables basically in GitHub Actions workflows. So you're just setting an environment variable. A repository secret or variable will override an organization secret or variable. So repositories are more specific. They override the default organization secret or variable if it's set. And then repositories can contain environments, which are essentially a named collection of secret and variable overrides. So, for example, if you wanted to have multiple different target orgs and you want to have workflows that work against the variable named target org or target org auth URL, you could have multiple environments, and each environment would, an environment named production, an environment named staging, an environment named UAT, and each environment would define its own target org auth URL. So when you run an action against that environment, it would override that variable. You don't need separate scripts. You can use the same scripts with the same variable names using environments. And then there's also a special input type for workflow dispatch and workflow call events called environment that basically builds a pick list or a choice of the environments that are defined in the repository. So for workflow dispatch, if you created a workflow that's going to be run manually by a user in the browser, they'd get a drop down to pick which environment they want to run against, and the right environment variables get passed in. So this is a really critical part. Sorry, my dog's going crazy. All right. So next up is deployments, which are correlated with environments. Deployments are basically an asynchronous job queuing system that tracks the deployment of a ref, a commit, a branch, or a tag to an environment that's defined on the repository. I think deployments are one of the major underutilized features in the Salesforce ecosystem, and this is something that I really want to try to figure out how to use more. Over on the right is actually sample code of from the first product that I'm building for MuseLab, D2X Cloud, of using a Python GitHub API client to go post a deployment. You can see they're relatively simple. It has a ref, an environment, a description, and then a payload, which is a JSON dictionary of information about the deployment job. So you basically just post that up to GitHub, and it then sends an event out to any app that is listening, and those apps are responsible for running the action of the deployment. So it's a really cool way to plug in all sorts of external deployment systems. And then GitHub has in its UI a way of showing you all the deployments against individual repository, against individual commits and repositories and things like that. Also, integration apps like the Jira for GitHub integration app by Atlassian will pull in deployments from GitHub and show them as deployments in Jira. So I think this is something that really should be utilized a lot more. All right, so the last on the CI/CD front is a new feature. I will confess I have not played with this feature yet, but I've read about it and I'm really fascinated by it, so I think it's worth calling out. And this feature is called merge queues. So basically, merge queues, let's say you set up a merge queue on your main branch, and you have 5 pull requests that you want to merge into the main branch at the same time. Or in quick succession to the other. Typically, the best practice would be merge the first one, wait for the build to complete, merge that into the next branch, merge that branch in, continue down the sequence, and everything has to happen serially. What merge queues do is they actually allow you to build an integration of the pull request versus the branch that it's targeting. And it builds a queue, which sets up a stack of all the PRs that are added to the queue. And when an integration happens, it not only integrates main, but it integrates all the other branches or all the other pull requests that are before that one in the queue into it. So it's kind of automatically doing this this integration, really continuous integration build for you. And then assuming that the build is successful, it will complete the merge. So it allows you to kind of quickly queue up a bunch of merges, assuming everything goes through. GitHub merges them as quickly as possible without you having to kind of stagger them. I think this is really cool as well, especially for deployment to an individual Salesforce org where you really care about making sure that everything is happening in the right sequence. All right. So next is getting into process and compliance related functionality in GitHub. So this is, anything to do if you want to ever go through a SOC Type 1 or SOC Type 2 audit. These features actually are very familiar to auditors, and so if you use them and leverage them, it actually helps a lot. Now, I have an asterisk on this one. This first one is totally optional. You could use Jira and other ways of tracking. But if you don't really have a way of tracking issues, GitHub has a pretty good built-in issue tracking system, and it's improving over time. You can categorize issues by labels. You can have GitHub actions that are triggered by certain issue submissions or actions on issues. So you can build kind of automated processes around your issues pretty easily. Another feature I haven't played with a whole lot, but I know others are kind of utilizing this to kind of automate some processes is GitHub issue forms, which actually allows you to define the schema for a form that renders into a web form whenever somebody goes to submit an issue of a particular type. So that's a great way of collecting data to automate particular processes, or just make sure that, for a particular type of issue, the users are providing the information that you need in order to be able to work on the issue in a more structured way. The kind of classic way of doing that is there were issue templates that would just be a text template that you could put headings in and things like that, and people were supposed to fill in. But issue forms is a little bit more formalized, and you're kind of capturing it more as semantic data. All right. So next, and related to issues, if issues are kind of where feature requests and bugs and things like that come in and are tracked, pull requests are what tracks the relation or the merge of change between two branches. So pull request is, for example, would say, I have a feature branch, I've implemented this feature, I want to merge this feature into the main branch. And a pull request operates in GitHub like an issue. It has actually an issue number, just like an issue does. But it has some extra features on it. Like you can do code review line by line and leave line by line comments and have discussions about the changes that are being made in the diff for that particular pull request. You can have status checks, so any of your builds will report back their status, and you can see that visibly on the pull request. You can also build draft pull requests, so you can kind of prepare a pull request before you go through and do that. And there's a lot of automated checks and rules, which we'll talk about here in a minute, that can be applied to pull requests that enforce a whole bunch of compliance checks. So pull requests are I don't want to cover them in exhaustive detail here. There's a lot of great documentation on them out there, but I think it's worth pointing out this is the main kind of gate where you apply most of your compliance checks. So one other kind of optional feature, you could use Jira, you could use any other issue management system, Agile Accelerator, whatever. But GitHub has actually been putting some work into redesigning GitHub projects. And GitHub projects is quite cool, I have to say. I've been using it a little bit in some of my recent projects for tracking just kind of rollout work across many different repositories and things like that. It has a pretty clean, simple user interface. You can have tabular views or Kanban style views where you can drag cards kind of along the way. You can create custom columns and statuses and fields on the tasks that are tracked in the particular project. You can link issues and tasks to repositories. So a project lives at the organization level and then can relate out to multiple different repositories. And then finally, you can quickly create tasks. So you just kind of type a task into a card, and then you can convert that task into a formal issue later on. So it's a great way if you just want to like sketch out a roadmap or something and just type quick sentences and then go back and fill everything in. It's a pretty good, quick user experience for doing that. So if you don't have a good way of tracking projects and you're looking at kind of moving your work into GitHub, you might want to take a look at GitHub projects. So I mentioned the compliance checks, and there are three main kind of rules three main sets of rules that make up the compliance capabilities of GitHub. The first is branch protection rules, which have been around for 5 or 6 years at least. And these are specified per repository. You target a branch by a matching pattern. So you give it a pattern, it can have a wildcard in it. It's not a full regular expression though, so it's a little bit limited as far as what you can target. And it's only a selection, an inclusion pattern. And then you can apply rules like required status checks, required reviews, you can restrict branch deletions, things like that. In the middle of one of my current client engagements that I'm wrapping up, it was late last year, GitHub came out with, or early, fall of last year or something like that. GitHub came out with this new feature, repository rules, or I think it's repository rule sets actually. And these are really cool because for the project I was working on in particular, we had 15 GitHub repositories that we were rolling out a DevOps process across each repo. And so repository rules are defined at the organization level and then related to multiple repositories. They have a better matching pattern for matching branch names that has include and exclude. So you can get a lot more granular with your targeting of branch names. The drawback of them is they have really limited support for status checks. So you still kind of have to use branch protection rules to enforce status checks, but you can enforce a lot of the other stuff through repository rules. And then finally, if you use environments in your GitHub Actions or you're using deployments directly, you can set up deployment rules on individual environments. So for instance, you could say a deployment to my production org has a break glass delay of 15 minutes. So when the deployment is submitted, it will pause for 15 minutes. And anybody can go in, or so that somebody could go in and cancel it if they realized it was a mistake. You can also require certain people approve that deployment. That deployment will sit in a queue. It's not actually running. It's not using worker minutes or anything. It will just sit in a queue until the right approvals are in. Then it gets scheduled for running an operation. And you can also restrict deployments to a particular environment to a particular branch. So you can say only main is allowed to deploy to, or main branch is the only branch allowed to deploy to the production org. So there's a lot of functionality that you can build in here, and we'll take a look at what these look like in GitHub here in a minute. I think they make more sense when you can see all the different options that you can configure. If you haven't really dug into these are really critical to building and locking down GitHub repositories and enforcing process. So the last one, this is a new beta feature that came out and wound up using actually in the project that I was just talking about. And this allows you to, it's called repository properties. So this allows you to basically just create property fields that are applied to individual repositories. You can set the fields to either be controlled by the organization admin for each repository, or you can allow repository admins and owners to set the values for their own repos themselves for individual properties. So if you think about any sort of like corporate-wide mandate that applies across many different GitHub repositories, I haven't seen this necessarily, but I think this is the reason that GitHub is building this kind of functionality, is it allows you to, track those different compliance requirements that you want to know per repository. Are we compliant with this requirement? Yes or no? And you can build a self-reporting interface for it. This feature's in beta now. I really expect that GitHub's going to build much more UX around this feature than what's here now. It's got the data model and the general mechanism for setting the data, but I think you'll see more analytics around this, like kind of reporting at the organization level about compliance. But the other thing, in addition to just kind of tracking, key compliance metrics and such, you can also use these to trigger repository rule sets to apply to a repository. So a repository rule set can be set to look for the D2X branching model property being set to yes on a repository. And if it is, it applies the rule set. So you can build one rule set at the organization level, or you can build 5 rule sets at the organization level, each one triggered on this one property. You apply the one property to a repo and all those rule sets apply to it. This is really great if you're managing many repositories, and a new feature that I was fortunate to stumble onto because it was really useful in that last project. All right, so and then the last category, and then we'll kind of jump over and look in GitHub. The last category is artifacts and collaboration. So from an artifacts perspective, I think it's interesting to think about the release-related artifacts that GitHub provides. So Git itself provides tags. One thing I think that a lot of people don't realize about tags is that there's actually 2 types of tags in Git. There's a non-annotated tag, and then there's an annotated tag. I forget the exact details. I think one is just a ref, one is a ref that points to a tag that points to a ref. And that's an annotated tag. But annotated tags can contain extra metadata, like who created them and when it was created. They also have a description field, which is just an open text field that you can use to store JSON data in. And then releases are related to a tag. You can set them as pre-release, which is useful for tracking beta releases. They have a body field that tracks, you can put release information or the install links for a package or things like that into releases. Something to point out here is that Cumulus CI uses these two places as the place of storing package release artifacts instead of having to edit the sfdx project.json file. So if you've done any packaging with SFDX, what you'll find is when you do releases, especially if you're building extension packages, you wind up having to edit the sfdx project.json file a lot to put in the package version IDs. With Cumulus CI, we change that around, and instead of kind of looking to that file in the repo to resolve the package version IDs, we store that information in tags and releases as part of the release process, and then we can query it from the repo. So these are kind of places that you can store information and persist kind of state and other artifacts in GitHub that have some pretty cool creative uses. So the next is packages. This is not Salesforce packages. It'd be really cool if you could just toss a Salesforce package in GitHub. I don't really understand technically how that would happen, though, unfortunately. But GitHub provides a package registry that's available to all repositories for storing common package types. So if you are building a Docker image, if you're building an NPM package, I believe you can store those in there. Sadly for me, as a Python developer mostly, they don't support Python packages. I don't really understand why. But I do wind up using packages myself for D2X, which is MuseLab's own open source framework built on top of Cumulus CI to integrate Cumulus CI's process into GitHub easily. And one of the components of D2X is a Docker image that has Cumulus CI and SFDX pre-installed, so kind of all the build dependencies. And then it has a set of GitHub actions that are reusable that use that Docker image, so the actions don't have to install tools. They're just running on an image that has the tools. It's really easy in a GitHub action to build that Docker image from a Docker file and then publish it up to the GitHub package registry. In the repository, you can then label your images. So I have a latest and then a Cumulus CI next, which has kind of a next generation version of Cumulus CI that I features that I haven't contributed yet that I'm working on getting through that I built for some of my clients. And so I can have those two different tags of a Docker image that's available for all of the repositories that are using D2X to use. And this is really easy, integrated into GitHub, nice and secure and locked in with the whole authentication system too. All right, and then in terms of collaboration, Codespaces are really pretty cool. I wound up geeking out on them a lot earlier in the year. After I got a new laptop and really enjoyed the fact that I could spin up VS Code environments in the browser. Codespaces are built on the dev container standard, which is an industry standard for defining basically a Docker container image that's used for running VS Code or a remote VS Code environment. So the cool thing is, like taking the example of D2X, which has Cumulus CI pre-installed in it, you can spin up a code space on top of that Docker image. And in the code space, you basically have VS Code running in the browser with Cumulus CI pre-installed and even pre-authenticated to your dev hub through a secret. So it's really cool to kind of create these portable environments. It also means your dev environments are using a consistent set of tooling versions that are defined in a file in the repo for the project, which has a lot of benefits. You can launch these in the browser in about a minute. I'll show you one here in a second. And then you can run them locally in VS Code or in other IDEs with the dev container extension or a Codespaces extension. I think JetBrains and I believe IntelliJ and a few others have that as well. Then finally, for non-Salesforce development, which I've been doing a lot of myself lately, building a web service. If you're building a web service that you want to receive webhooks from GitHub and build some integration with GitHub, Codespaces are a really cool place to build them because it can be internet accessible. So you can actually be developing code in a VS Code instance in the browser that is accessible to receive GitHub webhooks instead of having to use something like ngrok or I don't know, any other way of allowing external traffic to come into like something you're running on your local system. Again, not really relevant in the Salesforce world, but if you're building something outside of Salesforce, some sort of web service outside of Salesforce, Codespaces are really cool in that sense. They're also really security isolated, like the repo contents are not coming to anybody's local computer. It's all running in the browser. Then the other feature that's a fairly new feature, I think it came out about a year and a half ago for GitHub, is discussions. You can run your own idea exchange like discussion and voting system in each repository. Even for internal use, this is really useful. You could allow all your internal users to be able to come in and vote on ideas and discuss ideas. It's also a great way to deflect issues because previously issues were the only way for somebody to ask a question or just get general feedback or something like that. Discussions are a great way to do that. And, you know, there's, like I said, bidirectional conversion to and from a discussion. All right. That is all of the individual features. I know that's a ton of content. Hopefully we can kind of piece all of this together and seeing it after this. But the last kind of critical thing to understand, all of those things that we just talked about are all accessible in the GitHub API. You can build GitHub apps, which are very easy to set up. They handle, you know, they authenticate as a user or as the app using OAuth 2 or a JWT. Then those apps, when you build them, you can specify what permissions you need. So do you just need to know somebody's identity? Do you need write access to their repo? Do you need to edit workflow files for their GitHub actions? Those are all different permission scopes that you can define for your app. And you can subscribe to different webhooks for specific events. So if you want to listen for any push or any pull request in a repo, you can easily set up a GitHub app that will do that. You have to run that app somewhere. I haven't really explored this. I presume that you could probably run that app with Apex, you know, REST endpoints, and you know, be able to receive some of those webhooks and stuff like that. But I generally build things off platform for that. And the last point is GitHub apps are nice. There's another option, which is GitHub OAuth apps, that basically give you access to everything in everything that the user has access to that's giving you access. GitHub apps are installed into an organization and can either be installed to all repositories or just to a specific set of repositories that are selected by the person installing, and then you can add new repositories in the future. GitHub apps are definitely the right way to go. They have higher limits, all sorts of reasons why. I think there's a handful of instances where an OAuth app might make more sense, but generally I'd steer you towards GitHub apps. And to give you two quick examples of apps like this and types of things that you can build. So there's an app that we built, launchpad.muselab.com. That app is designed to help people launch new GitHub repositories that are pre-configured for D2X, our open source framework for ISV style DevOps. And so that app actually uses two GitHub OAuth apps. The asterisk here is, sorry, I just haven't gotten around to converting these over to GitHub apps. I knew that I need to. That was, honestly, I built this before I realized that I should have been using a GitHub app. So there's two different OAuth apps that this app uses. One is called D2X Launchpad. The other is called D2X Launchpad Worker. D2X Launchpad is the persistent app. It is just getting identification, the authentication information of a person, a list of their organizations. And then when you go to actually create a repository, we need elevated access. And for that, we use a separate app that's D2X Launchpad Worker so that it can be transparent to users if something went wrong with revoking the grant. Because after we run the repo creation, we revoke the grant that we received for that particular app. Because I don't want this app to hold on to the ability to write to the repositories of anybody who uses it. So it has that, permission temporarily for a split second to create the repository, and then it revokes it and moves on. It's then using a cookie cutter template, which is just a Python project templating system. This is an open source repository, D2X template, that's out on GitHub for the repository contents. So it's basically running a template engine to render the contents for the right project type and the right project information that was plugged in. And then it uses the GitHub API and Cumulus CI to get a list of organizations for the user to select, and then to create a repository with customized contents from the D2X template. So it's an example of the types of things that you can build. It took, honestly, the trickiest part was figuring out the whole second two-stage use of apps and revoking the token and everything. That took an extra couple of weeks for me. But it was something that we wanted to have in place before we launched, because that's the way that something like this should be built. But this app took, a couple of weeks to put together. Not very complex, because GitHub provides a lot of the functionality. You need a good API client library in whatever language you're working in. You need to set up the app, and then you're just kind of plugging in your business logic for interacting with the different objects. And then the last one, which is, part of why this is near and dear to me right now, is our first product that I'm building for MuseLab, D2X Cloud, is basically a platform for running automation against Salesforce orgs from GitHub repositories. So this is built as a GitHub app. When you install it into a GitHub repo, a tenant gets configured for the organization. The repositories all get set up and configured. So I'm automating a lot of the onboarding process of kind of wrapping a full set of automation around these repositories in GitHub that are configured with automation using Cumulus CI, so that I can provide that automation out of GitHub through an API that you can build whatever user experiences you want to on top of. So a lot of the points that we've talked about today, I'm looking at integrating as part of the onboarding process of bringing repositories in kind of to this platform. And so doing a lot of direct work with this API over the last couple of weeks, especially. All right, that's the overall map of it. I am going to attempt to see if I can find... Okay. For some reason, I cannot locate my cursor. Okay, well, unfortunately, I think that my mouse just died on me in the middle of my presentation. Let me see if I can get it to come back here in just a second. All right, I think I might have an alternative. All right, yes. Okay, so, sorry, this will be a little awkward. I'm using my new Wacom tablet that I'm not used to. What I wanted to be able to show is kind of what this looks like in an individual organization. So I have a this is my my individual GitHub organization. It is part of an enterprise. So I have an enterprise account for GitHub. And when I look at the organization, you'll see it's part of MuseLab. This one, let me click. There we go. And there's other organizations. So this is one of the cool things about enterprise is that you can build different organizations for kind of different departments and teams or product lines. And that way you can kind of segment team membership and organization membership and access policies a little bit better. Gives you there's a lot of controls you can do at the organization level that you might want to be different. If you don't have this, then you wind up having an individual organization with everybody working in repositories in a single org. And that gets tricky. So that's one of the nice things about this for the structure of things. And then I'll show the repository rule sets because I think this is one of the, like I said, this is a new feature and I think one that a lot of people have not really tapped into yet. So I have 3 rule sets that I've got defined here. And if we look at these rule sets, they are, okay. So this rule set is to protect the default branch in the repository. So it's targeting a dynamic list of repositories by property, and it's looking at this custom property I was showing earlier, a D2X branching model set to yes. So if a repo has that property set to yes, this rule set will apply to that repo. And the other way that you can do it is you can also specify target branches here. In this case, I've specified just the default branch. So it doesn't matter if it's called main or development or whatever is the default branch in the repository, this rule will protect. And then in the individual rule, there's a lot of extra controls that you can apply, like restrict who can create branches that match this pattern, restrict who can update the branches, who can delete, require linear history, sign commits. This is actually a really great one to require just from an audit standpoint. It's a lot easier to just kind of have it on and require it and get people using it than to have to do it down the road. And then you can require a pull request before any merges are allowed to happen. Now this option here requires status checks. This is the one that I was saying is actually, I don't like the way that this is implemented in GitHub right now, honestly. And the reason why is because it doesn't really know the status checks that you have running across your repositories. I think you have to somehow set up status checks at the organization level. And I had a really hard time figuring out how to do it. So, to be honest, this isn't something that I am using. So I'm not enforcing required checks on this one, but I am saying that branches before they merge have to be updated. So they have to include all the latest changes from merge. And also block force pushes and then require workflows to pass before merging. So you can require that all changes made to the target branch have to pass a specified workflow. The problem is these are specific to an individual repository. So they don't really help you if you're trying to build a rule set that applies across many different repositories. Again, I don't really like the way that this is built. So to actually enforce that a particular build must have passed for a pull request to merge, you still have to use branch protection rules in every repository. But almost everything else you can enforce in this. The last, which I haven't really used yet, is that you can enforce metadata restrictions through these rules. So you can require that a commit message or the author email or commit email or branch name matches some certain pattern, and you can give a description of the rule that would be shown to the user when the rule is violated. So you can automate a whole bunch of your requirements and everything, and just have them baked into the process with these, which is great. Let me see if my mouse has returned. It has, yay. All right. And so to show what it looks like to apply those, let me just jump over to a repository. I just built this repository earlier using D2X Launchpad. So you can see here the initial commit from D2X Launchpad. Haven't done anything in this repo at all yet. But what I want to do is go over here and go to settings, go to custom properties, and because I set this rule to be settable at the repo level, I can change this value here. And just by changing this value, I've applied these three branch protection rules from the organization to this repository. So I created a repository with D2X Launchpad. That already set me up with the 3 stages of the build process that I need for kind of implementing the process that D2X is built around. So I've already got my CI/CD builds, and then just with setting that single property on the repository, I enabled all of the extra, all those extra rule sets against the repository. Now, earlier I mentioned Codespaces, and I wanted to show really quickly what that looks like inside of one of these repositories. So normally it used to be when you click on code, you would just see this local section, but they added this Codespaces section. And you can launch a new Codespace. To launch them with D2X, the best practice is to launch it with this ellipse and the new with options. I don't like this in the GitHub UX, but I'll show you why. It's because you can recommend certain secrets. These are your personal secrets, your personal Codespaces secrets configured on your personal GitHub account. But they have to be associated with each repository. So if I hadn't built a Codespace on this repo already, these would be unchecked, and I could check them to grant this new repo access to the secret before spinning up the Codespace. But you have to use the ellipse in order to get to this. And then you hit create Codespace, that goes and spins up Codespace. I already have one. It takes a minute or two, and it gives it, funny names, curly goggles and such. And when I launch this Codespace, this is VS Code running in the browser. It's running on top of D2X's Docker image, so it's already got everything pre-installed. It's also pre-authenticating to my dev hub using a secret that's being passed to it by GitHub automatically. So I don't have to have anything installed locally. I don't have to install Python to install Cumulus CI in order to get this available. And then inside of here, I can just run Cumulus CI now. So the standard command in Cumulus CI is cci flow run dev.org. The D2X Codespace also sets the org name dev as the default org, so I didn't have to specify an org in this case. You can see it's calling out to SFDX, talking to my dev hub, and creating a scratch org for me. So I know that this is, my dream for a long time has been, how do we bring kind of a version control based process and all of this to declarative users? This isn't there yet, but this is getting a lot closer. You don't have to install anything on your computer. You can run a few simple commands, and it's mostly point and click from there. But I think we can, definitely do better in building all of that out. All right. I am going to see if, I will confess that I don't know for sure how to find comments for this session. I would very much like to do that. I have been through a few rounds of trying to figure this out, and it's quite frustrating. Give me just a second. All right. I believe I have found the comments. All right. So I just posted in the comments thread. If anybody has any questions, I can continue going through and kind of showing some of the features that we've talked about in GitHub, just to show you what those look like. But definitely happy to cover any questions if they come up too. All right. So jumping back into here, I'm gonna jump out of the Codespace. And I'll show you the GitHub Actions configurations and sort of how those are structured. Because I tried to implement a lot of the best practices that I was mentioning earlier for the way that D2X is structured. So really following the don't repeat yourself principle. If you look at the workflows that exist in the repository, basically this workflow is what triggers it, which is some logic that the repository might want to be able to control. And then the other bit is what reusable workflow is it actually running from D2X's repository. And then finally, it's just what are the values for these three different secrets that this reusable workflow needs in order to be able to run. So there is zero logic in this file. And I think that this is a really important goal that you should try to have when you're building the reusable actions. And then if I look at the D2X repo that's pointing to, and I look at the GitHub workflows, that's calling feature test 2GP. This workflow here is set up to be called by another workflow. So it's using the workflow call trigger. It accepts one input, a Boolean for debug. If you want to turn on Cumulus-CI's debug mode for more logging output. And then it accepts these different secrets, some of which are required secrets. And then it defines the job. It's going to run on the D2X image from the GitHub container registry. So this is stored in the GitHub package registry and published through a GitHub action. So again, all kind of self-contained in GitHub and easy to build out together. And then it's going to set environment variables for the Docker container and then check out the repository, authenticate to the dev hub by running a script that's contained in the Docker container. Then it's going to set the org name feature as the default org. That's just a scratch org creation profile. Then it's going to build a 2GP feature test version of the package. It's going to set the package information as a commit status in GitHub. This is another example of kind of using GitHub to persist artifacts. Then it's going to run a feature test against the scratch org. And then it's going to delete the scratch org pretty much no matter what happens in the build. It will always delete the scratch org. So normally all of this logic would be in your repo. And if you work across many repos, you'd be duplicating this logic. And what will happen is you're focused on the scripts in the repo you're actively working on. So if you enhance something in the build scripts, you forget to copy it over to the other repositories and duplicate that functionality across. And you get all these build scripts that diverge from each other. If you use workflow call, you can avoid that. And then what you have in your individual GitHub repositories is very lightweight. And it's the same for creating a production release and for creating a beta version of a package. The other is that the dev container configuration, this is what the dev container.json files look like. And you can define the VS Code extensions, different options that you want to have. You can set up suggested secrets. This is what does the UI in GitHub that triggers assigning secrets to the new repo. And let's see. What is... Yeah, so then also under projects, this repo doesn't have projects. Let me go to projects here. So here's an example of a GitHub project that we put together just kind of to lay out, here's what it would look like to run an SI engagement through GitHub projects. And on here you have these individual cards are basically tasks. And I can add new items here really quick. So a quick task. And you can see it's just a draft. It's not converted into anything, but it allows me to, another idea. I can just quickly capture ideas in here, as I'm working and then convert this into an issue. select the repository that I want to put the issue into, and actually make this into a work item. But it's a pretty easy way to kind of sketch this stuff out. You can customize the status fields and the different coloring of the status field. You can add new fields to it of different types. So there's a lot of customization that you can do to kind of build and track a project through this that I think is really neat. You also can have a roadmap view and a tabular view for the overall project. I forgot that it does a Gantt chart style view as well. So pretty neat, built into GitHub, doesn't cost anything extra. And if you don't have a good project management system that you're, project management system you're happy with, and you're looking at kind of building stuff out on GitHub, you might take a look at it. All right. And I believe that covers about everything that I wanted to show. And we are about at time. I don't see any questions in the chat. I will say, if I missed any questions, I genuinely apologize. I will get that sorted out. If you post on the event on LinkedIn any questions, I will definitely follow up and answer any questions that you have. And I'll post a recap blog post about this webinar with the video and the slide deck here in a little bit. All right. With that, thank you all. It was a pleasure. We'll see you soon. Oh, actually, if you're at Trailblazer DX, if you're going to Trailblazer DX next week, come see my session in the App Exchange Theater at 2 p.m. on Thursday. I'll be presenting a session with my client Risk Connect about the kind of DevOps transformation and actually the origin story of D2X, which I was mentioning a little bit earlier here. So if you want to hear more about that project, you can come watch that session as well. And also, I'd love to hear your comments about future webinars and what kind of content you would love to see. I've got a lot of obscure information that I've collected over the last decade in this weird corner of the space, and happy to try to figure out how to share that in whatever way possible with the ecosystem. So, and if you do see me at TDX, come up and say hello, and I will